Okay, so today should be the end class, the finishing class for SQL part, structured query language. So we have learned most of the language in it, just like DDL, what is DML, what is DQL. Those are the most important steps. Yesterday we learned two more things, that is DCL and TCL. Those are the things are just like controlling part. TCL sometimes we use for committing purpose. Whatever we are modifying for DML statement, those thing needs to be committed. Just saving the thing in the database itself so that everyone can see the changes. Okay, so that thing we have learned in yesterday session. Today, few more things. Actually, we have covered SQL as as a database component only table. Okay, but there are lots of component available over there which are in use in SQL. That is called view. One thing is called store procedure. One thing there is another thing. There is materialized view. Okay, sometime interviewers can ask question. What is the difference between view and materialized view? Okay, what is indexing? So I'll be just quickly touch on this thing, and after that, I have given an exercise to do yesterday. So I'll be just covering the same thing. This should be a real time scenarios exercise, so that should be helpful. If you can solve it at your, then that would be fine. But I'll be just quickly go through on top of that, what how to do that thing and all. Okay, that is real time as well as this kind of stuffs you can also receive in your current organization, or you are going to join any organization. That kind of exercise you can, or you have to face. Okay, this kind of project work you have to go through. Okay, so first of all, yeah, let me just cover up this thing. So we learned what is database. This is called database. Okay, this is called database. Okay, inside the database, the first thing comes up table, and table is the most important thing or basic thing we already learned. Okay, so on top of multiple tables, we can create select statement or DQL. Okay, and maybe joining, maybe doing some union operation, maybe lots of various things, maybe group by thing, those kind of stuffs, aggregation, sorting, those kind of operation we can do on top of multiple tables to build a particular business logic. Okay, so based on the business logic, I need to implement some business logic. I can check that a 10 or 20 tables is required to build that business logic, and multiple operation will be required. Okay, and the output of the business logic, that means the select query output of that entire query. Maybe there are 20 joins are there. There are some aggregation functions, all the things. So we need to run the query each time and we can get the output. Instead of doing that, we can create a view on top of that select logic. Okay. That's, we can give a name to that view. Suppose view ABC. Now we have the view ABC with us. We can trigger it anytime. We do not have to run the entire logic or build the entire logic every day. If the logic is very much useful and repetitive in nature, we can directly do select star from this view, or any data manipulation or any DQL required. The same operation I can do, whatever I'm doing on top of table, I can do on top of view. Okay, I'll be just quickly going through that thing over here. Okay, let me just quickly show you. Then only we can check it. Okay, suppose if you could remember some days ago, we have performed some join. So let's do that thing. Select star from, let me pick up employee detail. Okay, employee ID is the common column. I am as, yeah, I can recall. So those are the two table, employee designation and employee detail. Okay, designation doesn't have data. I have inserted the data, but that time I didn't commit it. Okay, this is the commit button. We can click on there, or otherwise we can Just type commit and execute it. But that time I forget to do that. That's why in that particular table there is no record. Okay, just quickly let me insert one or two records. Well, I'm just executing a DML statement. Two, three more important aspect just to, just a note over here. SQL languages are not case sensitive. It is case insensitive in nature. Okay. We can put values, V as caps as well. There is no kind of issue on indentation. I can put any space over here. No issue. When we will be learning Python, we can see lots of things. Python is case sensitive. We need to use proper cases in each of the scenarios. We need to use proper space as well. Where the indentation is required, we have to put it in proper way. Okay. Why indentation is required, we will be going through this thing while learning Python. But just have a quick update. In SQL is very user friendly. We do not have to maintain all of the stuffs. Okay. Just we need to maintain some coding. I mean, some coding stuffs we just have to remember. Insert into employee designation. Just give me 1 second, please. Give me just 1 second. I'm just coming. Sorry, 1 minute. Yeah, I'm coming. Okay, apology for that. Just have some emergency over there in my household. Okay, just put data. Okay, I'm just putting this two only, one and two. Okay, trying to insert it. Yeah, it's inserted. I'm just committing it as well. So in future purpose, when I'll be using this table, that should be having data. Okay, just quickly run this query. It is fine. Let me join these two table. Select uh, A. Just joining between these two table on A dot emp id equal b dot emp id. Now what to print? A dot emp id A dot emp age and B dot designation. Okay, it's fine. So suppose I need that output daily basis. Okay, we have separate table and I need to create this kind of join condition daily basis. So instead of doing the entire query to be run daily basis, we can wrap this query inside a particular view. Okay, so how to do that? Okay, so let me just wrap it in view. So how to do that? We can put a statement, just same kind of DDL statement, create view as, okay, or create or replace. You can also put if there is an existing view, create view name. Okay, we need to give a view name as well. Sorry. So let me put view underscore ABC, create view. Those are the keywords, and this is the particular view name. Create view name as the entire logic. Okay, that has been executed. I can check the view over here in views column. I mean in views structure over here. Let me refresh it. It's not been. Yeah, view underscore ABC, VW underscore ABC. This is our new view. So I'm just discarding it. Just let me just only run on top of this one. Select star from view ABC. Instead of running this entire query, I can just run this query now. So I have wrapped everything, the every SQL logic inside a particular view. Okay, so this is the view name. Now I can operate this view as per table. Whatever table functions I have defined or whatever I have gone through, the same thing I can do on top of table in this manner, on top of view in this manner. Okay, suppose I need to put a filter. I can directly put a filter on top of view as well. The same kind of stuff should be there, but the view physically doesn't store any memory inside it. It's just it is having only the logic. Okay, okay, you can see it's just working same as a particular table. Okay, so that is understandable. Devi, Randeep, what is view? Can
Yeah,
you hear
yes, sir.
me? Okay, so yeah, one more thing that is, I mean, this kind of question you can ask. I mean, you can be asked, what is materialized view? So in the view, the main advantage is we do not have to store the value. We are not storing the value. We are just storing the logic. So when I am just executing the view query in backend, it will be executing the logic, the SQL logic over there, and it should be throwing us the output. Okay, so maybe if the logic is too much big over here, so lots of logic is being implemented there, then we can see if we are just triggering that select query on top of view, it should take lots of time because in backend it's executing the same query. Okay, so that's why materialized view is there. It's just a bit different over here. Materialized view, when I mean we are storing the data as well inside materialized view. It's not only the logic, as well as after firing the logic, what output should be thrown, the output data will be stored in materialized view. Okay, so this is the difference between view and materialized view, and this kind of question can be asked. Some not, I mean, to create a materialized view, it's not in our scope over here, but just a quick understanding, it's another component in database, materialized view, and it will be storing the logic as well as particular data, physical data inside it. So that our query is much more faster. Okay. Okay. Now, if you want to check, suppose we already have the view created, you can check the definition of the view. By checking it, you can confirm. Okay, create view. You can just okay. It's a newer way to create the view, but how to check this view definition? Let me check. Uh, Send to SQL editor. Create statement. Okay, create statement is here. Some extra comment is there, just like what is localhost and all. No need to check that thing. Okay, we can check from this way. SQL security view. Okay, this is the view name as select. Okay, this is the view logic inside it. So whatever we have declared while declaring the view logic, it's here. Okay. So someone is new to this company. Some existed view is already there, but to analyze the data, he or she might be have to check what is the inside logic what is the logic of the view. Then they can check in this way. Okay. Okay, that's fine. Going to the next topic, store procedure. It's also, a repetitive thing for some execution. Maybe I'm just going to create some DDL, DML. Okay, so this kind of thing we can perform sequentially, one by one, with a single go. That can be done by store procedures. So if we just create some store procedures, it will be stored over here. Okay, not only DDL, DML, some complex calculation based on users input and all. So this kind of a particular complex logic can also be done by store procedures. Suppose we want to create a table, we want to insert data sequentially one by one, then we have to create another thing on top of any other table, just like this. So we can create those kind of stuffs in store procedures. Let me just go ahead with one quick example. So let me create a table, a backup table, obviously. Create. Okay, employee table, there is no backup. Let me just create it. Or let me create another table which should be storing this data. Last time we have created this view. Okay. Even if I just executed this statement in a procedure itself, then it should be executed as well. The procedure is for execution purpose. We just have to run the procedure or call the procedure, store procedure, and inside the procedure, what statements are written over there, those kind of statement can be executed sequentially. Okay, so it's just like we are executing one step, one particular query at a time. But whatever sequential thing we are just putting over there, it should be executing in this manner. That's it. So I'll be just showing you. While doing the exercise and all, we can quickly show you how to do that thing. Okay. Okay. Now, what is index? There is another topic. What is index? So index is being used for performance improvement of the SQL table. The tables and all. So what is that actually? This should be under, some higher level over here. So maybe if you are quite, a bit experienced over there, then the recruiters can ask you about the optimization techniques. So suppose you're, while fetching the records from table, it is taking long time for the execution. So they may ask you what kind of performance improvement you can go ahead with that one. So you can go ahead in this topic, indexing. So just like for pages or for book, we have the index. Why we have the index? To find out something quickly. So we have the pages or page number over there at the index part. The same kind of stuffs can be done at the table side as well. So on the top of table, if we have any table on top of the table, just we have the command create index on top of table. Even we can do this indexing part over here as well from UI side. So how to do that? Just go to index. There is no index. Just choose the column on top of which you want to create the index. Basically, on primary key, we need to create the index. Maybe the primary key is a single column. Maybe the primary key is a combination of multiple columns. Okay, so just select those columns. So I'm just creating these two. Okay, no issue. I'm creating these three. I'm just selecting these three over here. Create index for selected columns. Okay, create it. Then it should be created over here. Okay, so when the index is created, then if we just, run the same query, we can see how much performance has been improved over there. My screen is a bit hanged over here. Give me 1 second. Or maybe, yeah, while creating the index from UI side, it would take some time and the things got freezed. Let me just close the instance and run the instance one more time to check whether the index are successfully added there. I think I have done the index on this table. Not this table. Okay, so this way indexing can be done. You can also do it some UI issue. Yes, you can see the index has been created. Yeah, I have created the index on top of this. This is the index created on top of these three columns. Employee ID, employee first name, employee last name. Okay. You can see it over here. Fine. Okay. So that is called index. When index is being built, then it is very much useful to use while fetching the query, because over here in our exercise or example, we are putting maximum 10 to 15 rows or records in a particular table. But in real time scenario, there may be millions of records in a table. Maybe we have billing information from a particular store. Okay, so lots of information should be there. So while doing just select star from this table, it will take lots of time. Maybe sometimes it should take more than 10 minutes, more than 20 minutes. Sometimes we can get some error, a timeout error, because of this as well. So on top of this table, if we just put some calculation or some joins with other tables, then the performance will be degraded much more. That time we need to use the indexing part to be applied for all the tables. Okay, then it should be much more faster for our query to be executed. Okay, okay, so now I am going to, is there any doubt from anyone? Nothing. So moving ahead with the hands-on exercise. So I just prepared this exercise. Yeah, it's also there for the last season as well. And this exercise is for, whatever we have learned for this entire session for SQL chapters. So on top of that, this kind of exercise I have provided to you. Okay. I hope you have also tried or you have gone through this thing at your side. But if you are, not able to do that thing, that's why I'll be just repeating the same thing over here. So you can tally your result or you can tell your procedure how to do that thing by your own way. Okay. It's nothing but whatever we have learned till now. It's just like this. Just a quick recap for SQL session. It should be helpful. Okay. Give me 1 second. Okay. So what is the thing? Let me open that Excel. Okay, so it's telling create table based on each of the plants data. In Excel, we have three plants, plant 1, plant 2, plant 3. Okay, so create tables based on each of the plants data. We have to create individual table for plant 1, plant 2 and plant 3. Okay, so this is the first step. And after creation of the table, first we need to run the DDL. Okay, so after running the DDL, we can create the table, but the table should not be having any data. So after that, we have to insert the data referring from this Excel sheet. Okay, then we need to merge all the three data set in a single data set, and that should be stored in a particular table as well. So we can see in the three sheet, plant 1 and plant 2, plant 3, the column name is same, product ID. I mean, each of the plant should be having each product. So you can see just like the naming convention for plant 1, there is 101, 102, 103, 104, this kind of stuffs. Plant 2, plant ID is 2 and product ID is 201, 202, this kind of stuff. Okay, and plant ID is 3. The product which are getting generated in plant 3, it is this, and those are the product name and MRP. The same product name and MRP are present for different product table as well. Okay, we can see this thing. So as the product, I mean, those are same. The column are same over here. The columns are same over here. So we can merge this thing, means we can do union operation between these three tables, and all the data set should be merged in a single table. We will be having all the plants information 1, 2, 3, and all the things should be merged one by one. It is just like simple union all operation. Okay, let's do this thing quickly over here, step by step. But if there is any stuck point from anyone, or if it differs from your result, please do ask me. But this is a real time scenario we need to face, or we can get in our present organization. If you have already joined as a data engineer over there, so this kind of scenarios you can face, you have to handle the data in this manner. Okay, so let's quickly create these three tables, plant 1, plant 2, plant 3. Okay, so create table name. Okay, let's put plant 1 as a table name, plant 1. Okay, four columns are there, product ID, plant ID. Okay, let me just keep it, take it from here, paste it over here at the below. Product ID, product ID is numeric in nature, I'm putting integer. Okay, plant ID, it's also integer, let me put at integer. Okay, why I'm not doing plant ID integer. Then product name, it's varchar in nature. Suppose varchar 20. Okay, and the last thing is MRP, maximum retail price. Okay, so this is the printed price that they are printing on top of this product. Okay, so MRP should be integer in nature. Okay, so this has been executed. I can just check whether plant table has been created. Okay, now I'm just going to insert plant table, I mean the data. into plant table. Okay, so I can just pick one records at a time, or we can just put in insert command. Rather doing that, I can just uh, put some Excel logic over here. Let me just merge this one for all the columns, all the records, and do some concatenation to get this thing within bracket. Okay, so put concat. Okay, Excel concatenation function. Let me take it reference. There should be first race. It should be closed by one bracket. It's fine. Yeah, just I'm putting a Excel logic. Okay, so let me just bring it up. Just I need to put insert into table. If there is any doubt or any stuck point, kindly ask me. Insert into plant one, values. Okay, so we are inserting values. But those are bulk values. We can do this thing in this way. So values, this is the first record, put a comma. The second records put comma, third records put comma, comma. The last one we do not have to put anything. Okay. So plant one record has been inserted. Let me check quickly whether it's fine. Yes, plant one is fine. Let's create plant two. For plant two, it is same DDL. So it's something in repetitive in nature. So just creating plant 2 table. Okay, it's been executed successfully. It's fine. Let's check plant 2 data. Okay, so let me just take as the value is same. Let me put it over here so that I can get the same exercise. I can get this formula. Okay, I'm taking this one and now executing this thing as well in plant 2 data. No issue. I'm assuming. Okay, so plant 2, I'm inserting the data taking from Excel. Okay, it's executed. Let me check plant 2 data. Okay, it's fine. Let me put plant 1 as well. It should be required. Okay. So the last one is plant 3. The similar way I can create it for plant 3. Let me first create the table over here. Plant 3. It's been executed. Plant 3. Okay, plant 3 is also there. Let me quickly verify it. Okay, so all the plant 1, plant 2, plant 3 data has been inserted as per the Excel sheet. Okay, so our first target is completed. It's completed. You are correct. If you have been executed this one, then you are correct. So we have three particular tables storing each of the plant information. Okay. Now for the second one is very simple. There are, I mean, same thing, same columns, but the data is different based on different plants over there. So how to merge? Means we have to union this thing, union all. We have learned the set operation some days ago. So just put union or union all. There should not be any issue because union just like remove the duplicates. But over here, each of the plant we do not have duplicates. Each of the plant, the first plant is storing plant 1, second plant is storing plant 2, the third plant is storing plant 3 information. So union all between this, union all, we can do any union or union all anything. Okay, just run it. Yes. So plant 1, those are plant 2 data, those are plant 3 data. But we need to store this information in a particular table. So just put create table, suppose plant, only plant. Okay, create table name as, then the entire select query. So you are asking some days ago, we can whether put bracket or not. Yeah, we can put bracket or we cannot put bracket over here. No need to worry about it. But we can put it over here. That should be looking nice. Okay, it was yesterday's class. We have create one table based on some logic. Okay. So I'm creating a plant table containing all the plant information. It's executed successfully. Let me quickly run plant table to confirm it. Okay, everything is there. So we are successfully, we have achieved the second point as well. Okay, so what is the third one? Create store table based on the data in store sheet. Okay, there is another table we need to create. Store table. So let me just put it, take it in this manner. Any doubt from anyone? Randeep, Devi, if there is any stuck point, whatever we are learning. Randeep, are you
Not
there?
from
Yeah.
not
Okay.
from this. It's all clear. Just I have a little doubt, like when we were doing that indexing and all that stuff, in that
Mm-hmm.
you have few dots like period, like thing that is not clear why you were putting that period like.
Okay. Let me just quickly cover up this exercise. We can quickly go
Yes.
to this
Sure.
topic once more. Yeah.
Thank you.
Okay. Yeah, yeah, no issue. Let me create the store table. This is the third step. Okay. So let me just put the store columns name over here. The store ID should be here. Store ID, it's in numeric in nature. Okay. Then product ID 1. Why 1? I'm not sure. Let me put in this way. Both of them are integer in nature. Let me check. Yes. Okay, both. I mean, all the four columns are integer in nature. Discount. Let me put only discount. Quantity sold. Quant sold. I'm just maintaining. Okay. Yeah, discount should be integer in nature. Okay. And the table name should be store. Okay, I think it's fine. Let's execute it. Yeah, it's been successfully executed. put store name. Okay, the values. Okay, let me just do this same exercise over here, or rather I can just take the same thing. Those are 4 records, so there'll be no issue. Yeah, there'll be no issue actually. If I just put it over here and run it, only one inverted comma or quote should be coming for the third column, but there will be no issue because, okay, over here, yeah, there will be issue. If we just put a quote, that should be treated as, mm, let me check the function. If I just eliminate it, yes, now it's fine. Okay, I just, because if I just put quote over here, it should be treated as a string. Okay, if it's a string, in the fourth section, in the fourth question, there is some operation on top of numerical value. So if this is considered as a string value, then while doing this numerical operation, we can receive a error. So that's why, as this is integer in nature, all this value, so let's do not put, not put quote. Okay, quote should be used only for varchar or string. Okay, varchar and string is same. Just to show you or just for your reference. Okay, so insert into store, put all the store thing. Just I need to put commas over here. Okay, I'm executing it. That has been successfully executed. Let me check the store table as well. Yes, all the stored data has been stored over here. So third point has been successfully done. And the fourth one is the most important. This is for the aggregation functions and all, having some joining part as well. Okay, how to do that thing. So till third point is completed, let me put a quick comment whether all the data can be saved inside the table. I'm just deleting those stuffs from here. This stuffs as well. This is completed. We have now plan table. We have store table. Okay. Now we need to merge these two table based on product ID because product ID is a common column. You can see product ID is there. Product ID is there as well with a different naming convention. Product ID 1. Okay, but those are same data in each of the store when that particular product is being sold in multiple outlets. So we have to mention the particular outlet ID, that is store ID. The product ID, it's coming from the plant itself, and each of the store is having different discount percentages. Okay, just like you can see 101 is there for store ID 11. They're giving the discount 20%. Okay, and there is also a product, same product 101 is in store ID 15. Okay, so the discount percentage is 15 over here. That's how we can see the quantity has been sold over here 40 and over here it's 10. Although the product is same, but based on the discount the particular store is giving, particular crowd is purchasing the product to this store only. Okay, so based on I'll be just okay, as per the requirement. What is the requirement? Let me quickly check. So the business analyst want to check which store has sold. What kind of revenue is there? Not revenue exactly, the transaction for each of the plant. Okay, so we need to join the plant information and store information based on product ID. Let me just quickly do this thing. I have to join this plant. Let me put P. I'm aliasing this plant as P, store as S. Okay. So P dot on. I have to put join over here. P dot product ID equal S dot product ID 1. Okay. Okay. Just let me quickly put P dot plant ID. So I'm just joining between two data set. I'm giving plant ID. I'm taking plant ID from P table. Let me paste the product ID too. I'm doing an inner join, so no need to worry about it. Product name is not required. MRP is required for my future calculation. P dot MRP I'm taking. Okay. From store, we need to take the rest of the information. Let me check the store table once. Join, we have to perform the join very carefully. Okay, stored ID is required. Let me think about it. Now we will be working on top of plant. So plant and product ID is fine. So stored ID is not required. Just I'm picking discount, age dot discount and age dot quant sold. That means quantity sold out. There should be underscore. Let me quickly run it. Yes. So based on plant, we have this information. That is fine. Let's do one more thing. We have to calculate each of the column. So that is MRP. We are getting 20% discount on top of MRP. And how much quantity is sold? What after the discounted price, we just have to multiply the total quantity sold. So that should be the particular output. I mean for which what transaction for a particular product that we can receive in that particular column. So let's calculate a column over here. It's a calculative column. So based on MRP, we will be having the discount. Okay. So I'm just writing the formula MRP multiplied by, okay, 20% is discount. So the price should be 100 minus discount divided by 100 as it's a percentage value. Then again, we can multiply it with quantity sold. Quant sold. MRP is P dot MRP as well as consult S dot consult. So this is the entire formula I'm just writing. Okay, let me just quickly print it, whether it's working or not. Okay, so I think it's working. 80%. Okay, let me just quickly do this thing and my calculator as well for one thing, whether it's working properly or not. So 80% of 1800, that should be 80 multiplied by 1800 divided by 100 into 40. Yes, that is absolutely correct for one product, and that should be fine for other product as well. So it's fine. Just put over here final price. I'm aliasing this thing as final price. Okay. So for each month transaction, we are receiving the final price. Okay. Now we can eliminate this thing as well. It's not required for our calculation. Just make it simple. Whatever is required. Okay, we just need this thing because at our output, final output, whatever we require, and visualize. What should be our final visualization? It should be printing each of the plant's total value. I mean total sale value. Okay, so just I'll be doing this should be inner query. From this, I'm just taking another thing. I'll be just aggregating final price. Let me do this thing. Sum of final price. Okay, and plant ID. Grouping by plant ID should be there. And I'm taking data from this inner query. So select this from this query. Let me alias this query. Just put group by plant ID. So based on I'm just grouping by plant ID, I'm getting the summation of final price. That's it. Okay. I'm taking the data from this inner query. We have learned what is inner query yesterday or the day before yesterday. So on top of this query, I'm just selecting plant ID and final price. So grouping by plant ID, I'm calculating the summation of final price. Let me just quickly run it. Yes. So for the plant ID 1, this is the final price. Plant ID 2, this is the final price. And 3, that is the final price. So for each of the plant, which plant is having more profit and all, or more shops to reach and everything, we can get it from this output. Okay. So this is the last output, required output. I think there is no stuck point from anyone. If there is any, please ask me. This is very much important. We have learned everything over here. We have learned the set theory. We have learned the aggregation function. We have learned uh, the joining operator. We have learned the SQL, the calculation as well as the business. How to do that? To understand the business and as per the requirement, we need to execute the same over here. Okay. If there is any stuck point, please ask me. If not, then I will be wrapping up this session. Okay, so I think there is nothing. Just coming to your question, Randeep, can you please tell me related to index what you were asking for?
No, actually, it was not related to indexing. Like you were just putting S dot and P dot. What that dot means, like the point. It's for joining purpose.
Yeah, it's a alias actually. Let's forget this join. Okay, let me just put plant over here. No issue. So I can call this column over here in this manner. Product ID. I can also specify some more thing. We can put in this manner. Plan.product ID. It should be also working. Okay. So instead of calling only by the column, we can put this thing table.column as well. Okay. This is not required for a single table, but while doing for multiple tables, let me remove this. Let me remove this. Okay. So while doing for multiple tables, we have two tables now. Now I need to mention which column is coming from which table. Okay, suppose product ID is it's same. Product ID is present for both of the table. Okay, second table it's not product ID actually. Let me do one thing. I'm updating product ID. Okay, let me give you an example. In stored table, I think it's been stored with another name. Product ID 1. Let me rename this product ID 1 as product ID. Okay. Alter table name, that is stored. Rename from product ID 1 to product ID. Let me run it. There is some issue with the rename syntax.
Means it is to identify between the different tables, just for that
Yeah,
purpose
yeah,
it is.
correct, correct. So I
Okay,
have
okay, I
renamed it
got it.
successfully. Now, if I just eliminate this p dot over here, now you can see, just to show you once more time, store, you can see product ID. There is no product ID. So we have single product ID over here. So I'm joining based on these two, that is fine. If I just run this query, it should be throwing error because it will be asking for product ID is coming from which table, whether it's plant table and store table. That's why while doing the join, the ideal scenario, when taking up this column, we need to specify from which particular table, which column is coming. Okay, this is useful for the higher developer as well. If you do not put p dot plant ID, they'll be fine because plant ID should be coming from plant table. But product ID is common for both of the table. If I just going to run it, okay, here the error is column product ID is ambiguous, and the executor is not able to understand from which table product ID we should be picking. If we do not put any aliases over here or table name over here, there'll be no issue. But product ID, it's present for both of the table. Either I have to put h dot or p dot. Okay, if I run it, then it should be running. Okay, it's understandable.
Yes, yes, thank you.
Yeah, and we are aliasing it because if we just put everything, just like instead of p, we can put plant. It's bigger version. That's why while doing the join, generally we alias the table, and while calling particular columns, just we simply follow the convention alias name. It should be one character, two character dot alias name dot particular column name. Okay, especially we should not have to put alias in this case, because this particular column is present only one table. If we do not put these aliases, there will be no issue because quant sold is only from store table, MRP is only from plant table. Okay, but especially the particular column which is present for both of the table, it is required one, otherwise we will be facing error. But for the good exercise or ideal scenario or a good developer, they should put uh, whatever we have to fetch from each of the table. For sake of our understanding in I mean uh, next scenarios, or we are stucking for a particular issue, to debug the issue, we should have to put the column name, table name dot the column name. Okay, okay, that's all. uh let's connect the next day. Maybe tomorrow I'll not be there. I'll be confirming to Lohit or anyone whether the classes should be there for tomorrow. If I'm not able to connect, then I'll be telling you. Let's connect on Monday. If it's possible for tomorrow, we'll be definitely connect as well. And then we'll be covering starting Python as well as some business intelligence topics as well. So why we are doing data engineering and all that thing we should be learning first for 1 or 2 days. Then uh, we'll be going ahead with Python classes. Business intelligence is very much important, especially it's from the business analyst perspective. So, or the requirement perspective, how we can prepare meaningless data to meaningful data and store into table. So, especially if we have done the MBAs and all business analyst role or the architect role, they should be having this knowledge. What is business intelligence? So, after quickly learning this thing, we can quickly cover up Python chapters. Okay, so this is the plan. Let's connect Monday if we are not available tomorrow. Okay, that's all for today's session. Thank you. Bye bye.
Thank you.
Thank you. Thanks. Bye.